Hello everyone, this video is going to be about the assignment problem in the short-term scheduling chapter. So in the slides, assignment problems are solved using a method called the Hungarian method. It is the method detailed starting from slide 30. However, we are not interested in this method. We are not going to be using it. Instead, we will be using linear programming. I believe most of you are familiar with it. Okay, for most assignment problems you're going to see, the formulation basically has the same structure. However, it does not mean that you should simply memorize the formulation. You need to have basic understanding of the problem, its formulation, and how is it solved. So we're going to look at question 1 from tutorial 6. It is about assigning 5 detective squads to 5 cases, and here you are given a table that details the estimates of the average time that could be spent by each squad on each case. Alright, so to begin the formulation, we need to ask ourselves 3 standard questions. First of all, what is our goal? What is the objective we want to achieve? Now, for some problems, this can be implicit. However, it's pretty obvious. It says here that the objective is to assign the squads to the cases so that the total time to conclude the cases is minimized. The second question is, what can I immediately change or control? By answering this question, we can easily deduce our decision variables. So obviously I can't bring in more squads that would help me do the job faster. Also, I can't drop few cases to minimize the total time spent on all cases. So these 2 factors are not under my immediate control. Also, I cannot influence or change the time that could be spent by each squad on each case. What I can control, however, is which case can go to which squad. So there it is. We have our decision variables figured out. Each squad can either work on a certain case or it doesn't. So we have binary decision variables. Here they are. We're going to call it xij. It is equal to 1 if case j is assigned to squad I and 0 otherwise. So now at this point, the objective function is pretty obvious, but we still have to define our parameters. Parameters are the data given to you in the exercise. You have to define them, give them names or labels so that you can use them in your formulation. So we have m, the number of squads, n, the number of cases, so subscript I goes from 1 to m and j goes from 1 to n. We also have to name the average time spent by each squad I on each case j. I'm going to be calling it Tij. So for the objective function, simply have minimize the sum over I, the sum over j, Tij times xij. If you don't understand the compact form, try getting back to this simple form and maybe it will be clearer. Now we move on to the constraints. Earlier, I said that we have to ask ourselves 3 questions. We've already gone through 2 of them, and the third one is, what is stopping me from reaching my objective? Now, by answering this question, you can deduce the constraints. For other problems, this might be more explicit, like if you have available quantities of resources, your constraints will be very obvious. Here, it's a bit less obvious. The constraints are more of a logical constraints. They're kind of implicit. So we have 5 squads and 5 cases. So logically, our constraints are that we have to assign 1 squad for each of the cases, and we cannot have a case that is left unassigned. Also, you can't have an idle squad, so you can't put more than 1 squad on a case. To sum up this, we have constraint 1. It says that only 1 squad can be assigned to each case. Actually, this is not 1 constraint, this is a set of 5 constraints. For j equal to from 1 to n, we have the sum over I of xij's equal to 1. Again, if you don't understand this in the compact form, go back to the simple form and it will be clearer. Second set of constraints, each squad has to work on exactly 1 case. So for I from 1 to m, we have the sum over j of xij's equal to 1. And of course, xij has to be binary, so xij could either be 0 or 1. So that's it for the formulation. However, for this problem, we still have one more thing to do. In question 2, it says assign the squads to the above cases, but with the constraint that squad 5 cannot work on case 5 because of a conflict. So to do this, we simply have to add one simple constraint, which is x55 equal to 0. Okay, so that's basically it for the formulation. I'm gonna try to make another video for the Excel and Lingo part, but it's pretty easy. You can do it yourselves. You'll be asked to do it for the last homework I sent. However, I'm only going to ask for the LP. The solving the problem using Lingo and in Excel is going to earn you extra credits. And that's it, guys. Thank you for listening and good luck with your studies.